So the last human-induced weather condition that I'd like to talk to you about is not caused by pollutions or changing of atmospheric composition of the actual particles in the atmosphere, the gas forms that are found in the atmosphere, especially near the surface. The last form is called urban heat island, and this has to do with changing the substrate or the material that makes up the surface of the Earth. By changing the surface material on the Earth, we change its albedo, the albedo being the reflectivity of an item, right? Once again, if something is highly reflective, something like an ice sheet, it's going to have a natural bounce back. So the sunlight will enter through the atmosphere, hit that ice sheet, and then be sent back, reflect back out of the atmosphere. On the other hand, if the surface substrate is something that is highly absorptive, like plant cover, like vegetation, that sunlight will come down through the atmosphere, hit that plant cover vegetation, it would be absorbed, and in this case it doesn't even get reflected back, it's actually just absorbed and maintained. In this case, plants are going to use it to make sugar, so they're taking that heat energy and going through a whole process, so it's not going to add to the heat. On the other hand, if it's something like changing the substrate from something that would be vegetation to blacktop, or a bunch of glass surfaced buildings, or a black shingled roofing, or a tar-based roofing material, if I'm changing it to those things, the sunlight will come down through the atmosphere, touch the surfaces of those things, be absorbed by those properties, change from light energy to heat energy, right? So they're going to change into a different form of energy, and then that heat energy will radiate back out. And this is what causes places like city regions to be warmer than some place that should be exactly the same. So I can go to a place that's green and has a different surface material, and I will get a cooler temperature because the activity of what's going on with the sunlight is not being absorbed and converted to heat. And so I get a natural process of urban heat island, creating like a little island of heat in the middle of an otherwise balanced system of energy. Urban heat island effect is something that's common, and you will find it all over in most cities, especially with the dense populations and the more urban-like structures I receive. New York City is notorious for this. Think of New York City in the summer. If you were to travel into the city, even if you're on the same latitude from a different location, you'll get into the city and it will be 20, 30 degrees hotter. And everything on the street is just reflecting back at you, all of that heat energy. So it's just beating back at you. Think of the heat of the concrete. Think of the act of people scrambling eggs on the sidewalk. This is all something that you've experienced and you know to be true. Interestingly enough, one of the ways that we can combat an urban heat island effect is by creating a different substrate. So a different material on the surface structure that can break up this natural heat cycle that's occurring. So some of the stuff that we're doing is these green roof systems. And New York City is interesting because it's not as bad as it could be. And that's because without even knowing it, prior to us understanding or having the knowledge of urban heat island, we built Central Park. And we have this natural green structure in the middle of the city that keeps it from becoming just absolutely sweltering. It makes a huge difference. And all the measurements that we've taken in the sciences has created this very interesting knowledge that we now understand. But just understanding some of this heat storage and how it's happening, low buildings and how that heat energy will come in. So the light is coming in, it's being absorbed as heat energy. That heat energy is radiating out, and then the surface nearby is going, oh, I can absorb that too. I like heat energy, and it's absorbing, and then it's radiating it out, and so on and so forth. And so you get this little heating thing, where when we get towards really tall buildings, you can see how it just kind of builds itself into these little heat bubbles, right? So even though the sunlight might not be directly moving down between the buildings, there's this kind of pulsating heat that happens between all these surfaces within the location. We've talked a little bit about latent heat versus sensible heat. Once again, sensible heat is the actual heat that we are feeling based on temperature, which is a measurement of how much molecular activity is taking place. So how much vibration is the molecule having, right? And the higher the temperature measurement, the farther and faster the molecule is moving. Latent heat is a transference, and it's the act of the material changing phase. And the more material I have changing phase, the warmer I will create the location. And we've talked about this with clouds too, saying that when I flip from a dry adiabatic lapse rate to a moist adiabatic lapse rate, that act of changing phase releases just a little bit of heat, which means that the rate with which I will drop temperature, I will cool off, will actually slow. So instead of changing temperature at 10 degrees every 1,000 meters, I might change temperature at only 5 degrees every 1,000 meters. And we've already talked about this. So this is all review of things that you've previously known, but now you can apply them to something that is a human-induced action. This act means that if I have moisture in the city and I'm changing phase as water is condensing back on itself, it's releasing that heat energy from its gas particle as it changes to a liquid particle, and it's sharing all that heat to the atmosphere around it, creating humidity to the atmosphere and warming up that atmosphere, or at least allowing it to maintain its current temperature, not allowing it to cool off very well. Finally, urban heat island and the detection of climate change. We have to stay vigilant as we continue to work on these problems. It is something that as we pack people in, build larger buildings, look at the material that we are building with and find alterations or begin to record information so that we can just create long-term data spread so that we can understand what's going on. We can create better information, and with better information, we can create experimentation that might work and help with creating better living conditions for us as humans. Some of the stuff that really I'd like you to take away with it, with this whole chapter, with everything that we've learned, is that yes, weather cycling is natural, and yes, there's natural conditions. But yes, humans have also played a role in altering some of our natural weather and climate conditions as it stands. And that alteration is something that we are still just starting to grasp information on. And we don't necessarily know how to fix it, but without experimentation on how to fix it, without acceptance of there being an actual problem in place, we can't actually create solutions as we go forward. And so here we stand at the precipice of information, and weather and forecasting is one of those amazing subjects where the information that's coming out is happening daily, and it's not just professional scientists in the subject matter, but it's amateur scientists who are just doing their own research and measurements and looking at information, places, and data that are finding and making dynamic and progressive discoveries. And so overall, I hope you found this course interesting. I hope that you feel more comfortable with weather and the forecasting systems as they stand. And I hope you understand a little bit more about how humans are playing a role in what's going on in the Earth's atmospheric composition and what that might mean for our future.